what you have in front of you, you'll be able to see yours all together a little bit easier than mine. This is important for you to know for multiple reasons. Your math and science courses that you are involved in are going to include these from now on. I'm sure some of these should look fairly familiar to you. We've got alpha and beta, gamma, delta, epsilon, zeta, eta, theta. So alpha and omega is maybe something you see, that you've heard of before. Beta, all of them, yes. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, psi, omicron, pi, rho, tau, sigma, upsilon, phi, psi, chi, omega. Is that it? What did I flip? Sigma and tau. I said tau, sigma, didn't I? Yeah. All right. So yes, and that's something that, first of all, if you are going to be in a fraternity or sorority, you have to learn them during the rush process, but you may have professors in college that require you to learn them as well. Beta, that's probably something that you have seen in your science classes at some point so far. Gamma rays. Delta is definitely something you've seen in math and science. What does delta always represent? The capital delta, the change in. And so these are universal, meaning that it doesn't matter what country you're in, what language you speak, these symbols show up and they mean the same thing and they're consistent. Theta is the one that that should have been introduced to you at some point, but this is the main reason we're looking at it. Of this course is used for your unknown angle. So like your go-to unknown variable is x for the most part when you start algebra. For angles, we can use x as an unknown angle measure, but really the big boy and girl way to do it is to use this lowercase theta. It just looks like a circle with a line through it. But then it goes on and we've got iota, kappa, lambda, mu, nu, psi, omicron, and pi. Pi is probably the first one that you learn in school. Pi is not a variable, it is a constant, because the difference between a variable and a constant is that one varies and one remains the same, hence the name constant. So pi always represents the same number. Phi a lot of times represents a specific number that has to do with the golden ratio. And let's see, chi, psi, omega. And there's something else I wanted to, sigma is the summation symbol that you may have seen in math at this point. We talk about it in here, but it used to be in algebra 2. I'm not sure if that comes up. Anybody know what tau represents? Okay, so do you know how there are flat earth people? There are tau people, meaning that they think pi is terrible and tau is way better than pi. Tau is 2 times pi. So it's the value of 2 times the value of pi is basically what it is. And there's reasons that tau makes sense. So, there's just some people that are very passionate about it. But if you do ever have to learn it, so just like we have an alphabet song, here's the Greek alphabet to our alphabet song. And, okay. So let me turn.
Alpha, beta, gamma, rays, delta, epsilon, hey, hey, hey. Alpha, beta, gamma, rays, delta, epsilon, hey, hey, hey. Zeta, eta, theta, iota. Then there's kappa and lambda, mu and u and xi, xi, omicron, and then there's pi, rho and sigma and tau too. Upsilon, it starts with U. Phi and chi and psi are fun. Omega, and then you're done. Learn all that and then you're set. That's the whole Greek alphabet.
I'm going to test you on that. I just wanted to, and if you learn them a little bit at a time, like you know what delta is, you know what pi is, we've got theta. And there are some things I pronounce differently than I did it because there are some different pronunciations like phi and phi and even upsilon and kind of like Old English. There's different ways to pronounce it. So anyway, so let's today. Now remember, we're going to cut that in half and glue it on 81 and 82, and then we are going to be on page 80 with this. Okay? The information that we get today, this is hugely important. It's not going away. It is stuff that we have to be able to do to function through trig. Okay? Some of this should be a review from geometry because some of this is introduced to you in geometry. And some of it may not have been, but that's what we do today. You can have angles in the coordinate plane. When you draw them in the coordinate plane, here's my little x and y axis, then you have a side that's on the positive x, and then here's the other side of the angle. Okay, so it says angle plane is in standard form when vertex is in the origin, that's where it is, and one ray lies on the positive x-axis. Okay, the ray that's on the x-axis is called the initial side because that's where it starts. And then the other ray is called the terminal side because that's where it ends, that's where it terminates. You have the initial side where it starts and then the terminal side where it ends. Okay? And then we have we can rotate an angle starting here at 0. It can rotate counterclockwise or it can rotate clockwise. Counterclockwise rotations result in positive angle measures. And clockwise rotations result in negative angle measures. Okay? So this would be a positive, 120 or whatever, and then we'd have a negative angle coming this way. So when you first learn your quadrant, I'm not sure if you learned them in Algebra 1 or maybe it's before that when you start graphing things, the quadrant numbering system seems a little weird. You're like, why would I put 1 there? It doesn't make any sense. But once you start to learn stuff, then it makes a little bit more sense. If I start with 0 here and I'm going to open up and get bigger this way, it makes more sense that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay, because you rotate and your angle gets bigger and bigger and bigger. Okay, so that's, and hopefully what's going to happen as we progress through this step, a lot of things are going to start to make sense. This is the beauty of course. All this stuff you did in geometry, which you probably thought, like, I knew we were never going to use this, I don't know why we bothered. It's all coming back. You're right, you don't use it in Algebra 2, but it is important, and it is coming back, and things start to finally meld together and make sense. Okay, so let's talk about angles in the coordinate plane. It says the most common unit of measure for angles is the degree. So we know how to measure angles in degrees. It's the only way you knew how to do it up to geometry. So if 160 degree, so a degree is equivalent to 1/360th of a full rotation. Make sense? When you sketch them in standard form with the given angle measures. So we have 135 degrees. When we sketch an angle, we know that the initial side is on the x-axis. So there's where I'm starting, is 0. And then it's going to open up, is a positive angle, so we're going counterclockwise. So if I end up here, I'm at 90. And then I got to keep going. So how far past 90 am I going to go? How many degrees? 45, because if I subtract 90 from here, I get 45, right? So when you graph these, when you draw them on here, you do not have to get out a protractor and make them perfect, but you should be able to eyeball it and get it in a pretty darn close spot. Because if this measures 90 degrees, 45 is halfway, right? So go about halfway to like right here. You're not done, okay? You have to show the direction of rotation. I start here. Notice my little curvy arc is going to start on the angle. It's going to curve, and the arrow part ends up on the terminal side. So I'm saying I'm starting here, I'm rotating to there, and that is 135 degrees. Really, does it have to be touching? Not necessarily. it can't just be like thrown up there, and I'll show you why in just a minute, because that if you just kind of throw a little direction on there, it's really not 100% true, because the angles can get a little bit more wacky. So after we do a couple of these, then maybe that'll show you why. We'll come back to that. It's a good question. All right, let's look at 495. You may not even realize that 495 is a correct angle, but it is. You can have, an infinite number of degrees here. So we start still with this on the positive x-axis, right? And when I rotate around, well, 360 is going to get me all the way back to 0 where I started, right? So if I subtract 360, I can figure out how much farther I have to go. So if I subtract 360, what do I get? 135, which means that I'm here, I go all the way around to here, and then I end in the same spot that one ended in. So it looks the same. Except that it's not the same angle, right? That 495 degrees is a lot more degrees than the 135. It's just we ran around the track one more time. So I start here, and to show that this is what happens, I go all the way around and then back to there. See, if I just have like a little swoop over there, swoop, or just a little like arc, then that really wouldn't show that. Does that make sense to you? So it's, and I don't know if y'all did big angles like that or not, and that would be why it didn't matter, but that's what it needs to look like. What do you mean in your geometry? You were in my class. I was like, wait a minute.
Oh. Oh yeah.
Yeah, you were in my class. No, I didn't say that.
No, but someone told me, like one of my teachers.
Oh, it wasn't me. Yeah. And I was like, wait a minute. Hang on a second. Okay. And it's, because what some other students would do would like start at the origin and like do these weird like swirl things. I don't know what the heck that is. You're just showing that it's, so if it's not like, I'm not going to say, oh, it's wrong if it's not like not. That's not what I'm saying, but it needs to, actually show what's happening. Kind of like that right there, like what they have. See, like their little arrow isn't touching that, but it's pretty close to touching it the way they drew it. It's pretty close, so not a bad idea, just to make it happen so you're clear on what you want to do. All right, so negative 40. So I'm here at 0. Now I want to go in negative 140. So I'm going to go this direction. I go clockwise. That's a negative 90. And then I go how many more degrees? 50, which is a little bit more than halfway. And, it's so minor that it's really kind of hard to tell that. That's another reason why this is important here, because you got to show that you're going in this direction so that we get that negative 140. And this was 495. Okay.
Will the angle arrow go?
Far out from the origin? Is that what you're saying? Yeah, not necessarily. I mean, I could have started closer. I could have started a little farther. Okay, we all good? Okay. The whole reason this even comes up in geometry is because that's when you learn about radians and how to convert from degrees to radians. And it connects with that stuff because you've talked about arc length. So you talk about arc length in geometry, and then you get to radian measure. So it says that a radian is a unit of angle measure based on arc length. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intersected arc. So what that means is, this is the length of my radius. So these two things right here are obviously congruent to the circle. So when you find an arc length that has the same length as your radius does, that is the radian of the circle. Okay, and you can, if it's really just a ratio of the arc length to the radius, you can figure out what these are. Instead of talking about degree, about radius. And all the way from the circle, it says recall that the circumference of a circle is 2 pi r. So from here, the distance all the way around the circle is 2 pi r. Does that make sense to you? We talk a lot about the unit circle. So the unit circle has a radius of 1. So if my radius is 1 and the circumference formula is 2 pi r, what's the circumference of the circle? When you substitute 1 into here, what do you get? 2 pi, right? If r is 1, you substitute in there, you get 2 pi. Does that make sense to you? So 2 pi would be the circumference. Rotation all the way around the circle would be 2 pi r. So 360 degrees is 2 pi. That is a 3. Oh my goodness. I don't know what the heck is going on. 2 pi radians. Now we normally, even though like for 360 degrees, you have to put that degree sign. For radians, most of the time we don't put units on there. We are right here, so we know what we're talking about, but that's where we go with that. So if 360 degrees is 2 pi radians, and 180 is how many radians? Just pi, yeah, pi radians. Okay, so to convert, the converting formulas are very easy. Just multiply fraction. Now, 3 equals to pi, that's because it's one full rotation, one of the many reasons. But pi, I would connect pi with 180 better than 360 with 2 pi. I mean, you have to understand both, but this is what we use right here for our conversion. So if I need radians, like I have a degree measure, I take whatever my degree measure is, and I multiply by 180. It's just that means that my degrees don't have pi in them. Radians do, so pi has to be in the numerator. And if I want degrees, I take my radian measure and multiply by 180 over pi so that the pi's will cancel out and I'll end up with degrees. So whatever you're going for, if you want degrees, make sure degrees are in the numerator. If you want radians in the end, you make sure that radians is in the numerator. So it's either pi over 180 or 180 over pi. And honestly, if you think about what you're doing, it's kind of backwards. It's real easy to figure out what you're trying to do. See that when we go through there. Okay? So let's convert. To convert each angle measure to radians and state the quadrant. Right now, because you understand degrees better, thinking about the quadrants in terms of degrees is okay. So we can go ahead and decide the quadrant. If I have 60 degrees, what quadrant am I in? 1. Okay, so I'm in quadrant 1. We know that. So to find this radius, I'm going to take the 60 degrees and I have to multiply either by pi over pi. Pi over 180 because I want radians. That's what I'm looking for. So before you multiply, reduce. Okay? You have to not be afraid of fractions. You have to know how to so that things don't get difficult. I know I can divide them both by 10. That's what makes the zeros go away. And then can I reduce the 6 and 18? Yes. 6 goes into 6 once, goes into 18 how many times? 3. So in the end, I end up with pi thirds. So 60 degrees is pi thirds radians. I promise you, after you get through the initial, this is new and weird, that you will like radians better. They're easier to understand on the circle. They're easier to remember once we look at the patterns. But it's going to be a process. You have to not freak out during the process. You have to stay with me, and I'll help you work through it. I'll give you ways to learn it and memorize it, and it's going to be like a step-by-step thing. We're not doing it all in one day. All right, so let's look at 160. 160 would be in which quadrant? 2. Okay, so 160 degrees is in the second quadrant. So I'm going to take this 160 and multiply it by pi over 180 because I want radians, right? So then I'm going to cancel out the zeros. And then, that's because I'm dividing by 10. Then can I reduce some more? Yes, I can reduce the 16 and the 18 both by 2. So this gives me 8 and 9. So in the end, I end up with 8 pi over 9. That's my radian measure. Okay. Everybody okay with that? Yes?
So those never going to be any units?
Well, there are. You just don't write them. Yeah. All right, so then this negative 330, what quadrant would that be in? The first one, right? Because 330, I would be here, and I'm going negative. Up with quadrant 1. Good. So I end up in quadrant 1. And so I can take this negative 330, and I'm going to multiply it by pi over 180. I can cancel out the zeros. And can I reduce the 33 and the 18? I can divide them both by what? 3. So this becomes 11, and this becomes 6. So I get negative 11 pi over 6. Okay. Easy, yes. Now, I want you, even though I know radians, even if you learn, you learned them, you may not have used them that much, so they probably didn't stick with you much in either way. So I don't think any of you were like super comfortable with them. But I want you, even though we're not super comfortable with them, let's see if we can at least think about the quadrants before we convert. And then after we convert, we can see how you're going to have to learn to think around this circle. So we know that here we're at 0. To to what? 2 pi. Okay, so 2 pi radians for a full rotation. Make sense? This would be 180 degrees. How many radians would this be? You with me? 90 would be what? Okay, and how would you write that? Pi over 2. So it would be pi over 2. Always is one full fraction. As we go around this, because we're going to have different fractional values, you have to think in terms of fractions, which is an easy thing to do. So pi halves. So pi halves is 90. So I'm here at 0. This is 1 pi over 2. Yes? So this is 2 pi over 2 once it reduces, right? So then what would this be? 3 pi over 2. And then this would be 4 pi over 2, which is 2 pi. Does that make sense to you? So that's all we're going to worry about is these 4 right now. Get the 5 pi over 18. Just knowing this much, I should be able to figure out what. It's less than pi, right? Do you agree with that? Okay, so if pi over 2, what would the numerator have to be for that to reduce to pi over 2? 9. So think about 18ths. That would have to be 9 pi over 18. Is that more or less than that? Less. So that means it has to be in quadrant 1. Does that make sense to you? You just got to read through that a little bit. It'll get easier and easier. That's why we're practicing. This is 1. Okay, so let's go ahead and just do these quadrants then, and then we'll see if we're right in the end. Negative 11 over 9. All right, so going this way first. Let's think about what pi would be. Pi would be 9 pi over 9, right? So just 2 more of those not end up in the second quadrant. You see how it works? 3 to pi and 2 pi, you'll be good. So that we're in the second quadrant. Once we get the degree, check that we're right. So 7 pi thirds. All right, well, this would be 3 pi. A little bit more than one rotation. This will get easier and easier and make more sense. So again, just stay with me. It's okay that it's a little uncomfortable now. Yes, sir. Okay, if it's right on the line, it's called a quadrantal angle, and that's a very good question. And we'll answer that on the back. So hold on to the question. That's a fabulous question. Okay, so now we think, right, we're going to convert. So these are in radians. I want them in degrees. So 5 pi over 18, to get it into degrees, I'm going to have to multiply it by 180 over pi. So these pi's cancel out. Can I reduce? Yeah, 18 goes into 18 once. It goes into 180 how many times? 10. So in the end, I just have 5 times 10, and I have 50 degrees. Everybody okay with that? Negative 11 pi over 9. I'm going to multiply that by 180 over pi. So I can cancel pi's out. I know I'm going to end up with a negative number, so I'll write that down so I don't forget. And then, can I replace anything else? 9 and 180. So 9 goes into 9 once, goes into 180 how many times? 20, okay? So then I really just have to multiply 20 times 11. Does that give me? Negative 220. Good. And so do you agree that 50 degrees is in the first quadrant? Yes? Negative 220 is in the second? Okay, because it's sounds good. All right, so 7 pi thirds. I got 7 pi thirds. I'm going to multiply that by 180 over pi. The pi's cancel out. I can reduce the 3 and the 180. So I get 7 times 60, which is what? 420. Okay, so I get 420 degrees. And so I'm here. I go around 360 degrees. And then that would give me another 60 up here in the first quadrant. We good? Yes? Okay, just keep thinking about this. Try it, even though I know it's pushing you out of your comfort zone. It's going to get better and better, I promise. All right. So now it says angles in standard position with the same terminal side are coterminal angles. So let's look back at this one that we did. This right here, these two angles, they're clearly different angles, right? They end in the exact same spot. That makes them coterminal angles because you can only go so far and then you just keep spinning. It's like if we all went outside and we all ran around the track, we might all run a different number of laps, but if we all end at the finish line, that would make us coterminal angles. We ended up in the same spot, but you know, y'all all ran way more laps than I did. I can assure you of that without us even trying. All right, so it says determine whether or not they are coterminal angles. So what do you think I could do with these numbers to figure that out? Like, what could I add or subtract to the degrees? 360, because if I'm going to start here, whether I'm coming this way or this way, here to get back here, it's either 360 degrees, no matter which direction I'm going. So since this is positive and this is negative, and I want to know if they're coterminal, I can take this 305 and subtract 360. What's 305 minus 360? Negative 55. So we get negative 55 degrees, and so the answer here is yes. So what about with radians? What do you think I would add or subtract for radians instead of 60? What does 360 go with? 2 pi. Okay, so I'm going to take pi fourths, and instead of 360, I'm going to subtract 2 pi. But we have fractions. Remember how I said you need to think fractionally. You need to be able to very quickly change to whatever denominator you want. Well, this, hang on. I need to change fourths. So 2 pi in terms of fourths would be what? How many fourths? 8. It would be 8 pi over 4. So 2 pi is the same thing as 2 pi over 4. Does that make sense? Because if I reduce that, that's what I get. Wait, I think I said that wrong. 2 pi is the same as 8 pi over 4. I don't know what came out of my mouth. Because it needs to reduce back to 2 pi. So pi fourths minus 8 pi fourths is what? Negative 7 pi fourths. All right, so do these match? No. Now, just because they don't match does not necessarily mean the answer is no, because maybe I needed to subtract again, or maybe I needed to add again. But can I add or subtract any value of 2 pi or 8 pi fourths to this to get to the number? No, so the answer here is no then. Okay. Well, yeah, these things are kind of part of the answer because this is what we get, and then the answer is yes and no also. Like the whole thing is kind of your answer. All right, so number 14, we're just going to skip 11 and 13. It says give 2 coterminal angles for each given angle, 1 positive and 1 negative. Okay, so we have to make sure that we have one of each. So if I take this 150, I can subtract 360 like we just did. So what's 150 minus 360? Close. Negative 210. So I get negative 210 degrees. I could also take 150 and add 360 to it. And if I do that, what do I get? 510. Okay. So there are 2 coterminal angles, 1 positive and 1 negative, that both go with 150. All right? There are an infinite number of answers because I could add or subtract 360 again and again and again. We don't need to get crazy and find big ginormous ones, but that's why it's telling you 2 and making 1 positive and negative. There's not just one answer there. All right, so let's do 15. We'll skip 16. I want to add, well, I'll start by subtracting, I guess. It doesn't really matter, but 7 pi over 6. I want to subtract 2 pi. But what is 2 pi in terms of sixths? 12 sixths. So it'll be 12 pi over 6. Good. Like, don't let that scare you. That's got to be something that should make sense to you and that we can do quickly. So 7 pi over 6 minus 12 pi over 6 is negative what? 5 pi over 6. So there's one of them. Then I'm going to take that 7 pi over 6 and I'm going to add 12 pi over 6 to it, which would give me 19 pi over 6. What do you whisper about me? Oh, we ran out of space. I'm sorry. You can kind of squeeze it in 16. We're not going to do 16. Yay. All right. So Reference angles. This is huge too, because once we start to learn the unit circle, and you don't even really know what I mean by that yet, but once we start to learn that reference angle is in quadrant, you are golden, okay? And again, I will help train you through that, but when I tell you to practice certain things, you have to practice, or you're not going to get any better at it. So it says for an angle theta in standard form, the reference angle is here are the important words here. Positive acute angle formed the terminal side in the x-axis. That's hugely important. We don't care about the y-axis. It's the terminal side in the x-axis. It's always positive and it's always acute. Okay? So let's look at 150. So we're going to start by sketching that angle. What quadrant would 150 be in? A second. Okay, so here's my angle side. So the best way, you always want to think about the x-axis. So getting to and from pi or 2 pi is kind of the key to things. So if I'm here, I know I'm in the second quadrant, but I'm not going all the way to 180. How far do I stop before 180? How far left would I have to go from this? 30. So I stop, and so this is 90, so 30 is about a third, so I'd stop about right there. So this right here is 150 degrees. The reference angle is created by the terminal side, this side right here, and the x-axis. So this right here is my reference angle, and it would be 30 degrees. It doesn't matter which direction you go to get to that axis, it is always positive, and it is always, yeah?
That would make it supplementary, right?
Supplementary, yep, sure would. All right, so then let's look at, let's just jump to 4. Start thinking in radians here. 5 pi thirds. All right, so I know I'm starting here. So once I come around here, in terms of thirds, when I get to pi, 3 pi thirds. You agree with that? And then I keep going, and all the way over here, this is 6 pi thirds, yes? So 5 pi thirds would end up in the 4th quadrant. So I'm right here. So this right here is 5 pi thirds. That is my actual angle that I just graphed, right? The reference angle is created by the x-axis and the terminal side. So again, I know radians are not super comfortable with them yet, but let's think about this. You should know that to get here, right? For thirds, that would be it's a 5 pi thirds. How much do I have to get? Pi thirds. So my reference angle is pi thirds. Okay, does that make sense to you? But to get there, so let's get 13 pi sixths. So I'm going to start here, right? That's at 0. In terms of sixths, this would be 6 pi sixths at 180, right? Then this would be 12 pi sixths. So do I have to keep going? Yes, so I end up in the first quadrant right here. So from here all the way to here is 13 pi sixths. The reference angle is positive acute angle. Sixths is hard for me to say. Positive acute angle made by with the x-axis here. So how much farther than 12 pi sixths did I get? 1 pi sixth. So my reference angle is pi sixths. That's a hard word for me. Okay. Everybody okay with all that? So then negative 5 pi fourths. I start here. It's negative, so I'm going this way, right? So this is 0. This is 4 pi fourths. So I keep going, right? And then I'm up here like this. This right here is negative 5 pi fourths. So then I have this reference angle with my terminal side and the x-axis. What would my reference angle be? So close. Pi fourths. Because this got me to 4 pi fourths, so this is 5, so it's just pi fourths. And so yes, always positive, always acute. It doesn't matter which direction you're going or what it was before. Okay? It's just, it's like a distance. Distance is always positive, even if I'm going right or left, that sort of thing. then it doesn't really have a reference angle because we don't need it for the reason that we need it. And you don't really necessarily understand why we need it yet, but because of that, because it's on the quadrants, that makes them easier and we don't have to worry about them. So these technically don't have reference angles. Okay, that's a good question. That's a great question. Okay, we all good so far? Yes? Yes? Okay. So let's look at these quadrantals. So it says, quadrantal is just another form of the word like quadrant, right? So it says the terminal side of an acute angle, that is in standard position, lies on the x or y axis. The angle is called a quadrant. So if I asked you about one of these and I said, what quadrant is it and what is the reference angle, then you don't really have one, right? So you answer all of these with the word quadrantal, and then you have to clarify a little bit. 0 or 0 pi or even 2 pi, right? Even if it went all the way around, I end up at the same spot. And this right here, this is quadrantal angle, and it lays on the positive x-axis is what I was trying to write. So 90, which is this angle right here, that's quadrantal because it's on an axis. I do not have a reference angle, and it's not in a quadrant because it's quadrantal, so it is quadrantal in positive y-axis. Very good. So then 180 or pi is going to be quadrantal. I'm making y'all write that each time because I didn't when I taught it the other day, and then even though I said you have to write the word, nobody really paid attention to that. So, so this is now on the negative x-axis, and then 270 is quadrantal. Plus, if you remember the word that's new and weird, and this is on the negative y-axis. Okay. Any questions at all? Are we all good? You good on the reference angle? I skipped reference angles with degrees. I can go back and do them if you think we need to do them, or you think you're okay? You think you're good? Okay. All right. I think you're okay. I want you to be more comfortable with radians because everything's going to switch over to radians eventually, and you'll like them better once you understand them, okay? But it's a slow process, and it's all good. Eventually, you have to know a lot of this stuff. I don't expect that right now, but we'll get there. Okay, so go ahead, glue or tape those in right now. I was trying to see if there was anything I had to, no. Right now, because radians you're not comfortable with, okay, and I get that. If you need to, on these, convert them to degrees so you can wrap your mind around it and then do it, that's fine. Just make sure you're giving your answer, that I didn't box here, make sure you're giving your answer in radians. But if you need to figure out, like, are you having trouble with which quadrant and how much more to go back, okay, then I want you to try and think in radians, but if you're struggling with it, go ahead and convert it to degrees so it looks more like that, and then you can do it in degrees, find your reference angle, give me that in radians, and then eventually you won't have to go through all that once it starts to make more sense to you. Okay, is that okay? Okay, good. Anything else? Awesome.